parallel. Any ray that comes from the focal point, regardless of where the image or the object is going to come out parallel. Any ray that originates at the focal point will emerge from the other side of the lens parallel to the optic axis. Yeah.
So is that why when you look through a telescope, when you focus on the object, is that when you get a clear image, is that when the light's coming out at you straight?
That's when it's coming out parallel.
Now, when you focus too far in, you get that blurred picture, is that when it starts coming out all bent and stuff?
Yeah.
Okay.
So if you change the location of the eyepiece, right? So say we have it finely tuned right now, so that the eyepiece is 20 centimeters. Why 20 centimeters? Because it's the focal length of the eyepiece. Right? The focal length here is 90 centimeters. This is 20 centimeters. The two focal points have to coincide. The primary lens and the secondary lens. So if this is perfectly tuned, the light comes out like this. You can't project this on an image. You can't project this on a screen. Because it's parallel light. It's not focused this way. But when you put another lens here, called the eyeball, then the eyeball takes these parallel rays and focuses them to the focal point of that third lens. And that's ultimately how you see the image.
Would it be 100 centimeters for primary and secondary lens?
It would be 110 centimeters. Be 110 centimeters from this lens to that lens. Okay, so then if you were to move this lens a little bit closer, Kevin, right? These rays would be divergent. Now, your eye can handle a certain amount of that. It can adjust for a certain amount of that divergence. Right? But when it's comfortable, it's not working it hard at all. These are coming out parallel. Yeah.
It's like if you look at the full moon through the telescope, you want to put it on a piece of paper through the telescope. You have to focus it differently to get an image on a piece of paper. But when I want to look at it through my eyes, it's different. I have to refocus it.
That's right.
Instead of putting it on a projection.
Right. Yeah.
Got it.
All right. Everyone okay? So, for the refracting telescope, this is the simplest refracting telescope you can get. One big lens here, another small lens here, and you adjust the focus, which is ultimately determined by the mechanism of how you see things. You adjust the focus by adjusting this initial focus. But, you know, with any refracting telescope, you have these chromatic aberrations. One of the big things you want to do when you're looking at objects from space, you want to make them as bright as possible. Right? So how do you make an object as bright as possible?
Increase the lens size.
You make the lens bigger. Right? And the bigger you make the lens, the more likely the lens is going to get screwed up when you bake it. So there's an engineering issue of making very high quality, large lenses.
That would happen to the Hubble like a couple years ago or something. Screwed it up.